Hi, welcome to Chapter 12. We're going to learn about conic sections in this chapter. Now, conic sections, what they are is all of the two-dimensional figures that you can get by taking cross-sections of two cones placed on top of each other. Now, if you cut through parallel to the bases of the cones, you would get a circle. However, if we did an angle but did not cut through a base, we would get an ellipse. If we cut through at an angle and go through the base, that would create a parabola. And if we cut straight up and goes through both cones and hits both of the bases, that would make a hyperbola. So the four things are circle, ellipse, parabola, and hyperbola. So we're going to start by doing a little work in class. If you plot x squared plus y squared equals 1 in your calculator, you can't quite do it. What you need to do is solve for y, because our calculator has a y equals button. So first thing you do is subtract x squared on both sides, so y squared equals 1 minus x squared. Square root both sides, so y equals plus or minus 1 minus x squared. Now if you graph this on your calculator, you're going to get a circle with a radius of 1 centered at 0, 0. Now, it says use Pythagorean theorem. Using the Pythagorean theorem, explain why the graph is a unit circle. Alright, so if I should have made this bigger so I could explain this all at once, but that should work. Now, if say this has a radius of 1, that means I could draw a line anywhere, and that hypotenuse is 1. Now, if I draw a line straight down to the x-axis, we know this x and this is y. So where are all the points where 1 will be the distance from the center? Well, since this is a right triangle, we know x squared plus y squared is equal to 1. So all of the points that work for this will be exactly the distance 1 from the center, from the origin, I should say. Alright, so we call this the unit circle, x squared plus y squared equals 1. Now if we plotted this, 4x squared plus 9y squared equals 36, first solve for y and then plot it, you'd have 9y squared equals 36 minus 4x squared, because the first thing we'll do is subtract 4x squared from both sides. Now we divide by 9, so y squared is equal to 36 divided by 9 is 4. 4 divided by 9 is just 4 ninths. Now if we square root each side, we're going to get y is equal to plus or minus the square root of 4 minus 4 ninths x squared. If you graph this on your calculator, you have to type one value, the top one in for positive part, for y1, for y2, you type in the negative, and the same, square root of 4 minus 4 ninths x squared. Now plot this on your calculator, pause the video. Hopefully you saw that the result would be an ellipse. The ellipse from problem 2 is a dilation of a unit circle by a factor of 3 in the x direction and a factor of 2 in the y direction. Transform the equation to make the right side equal to 1 so that the equation is this form. So let's look at this. They say transform this to make it so the right side is 1. If I have 4x squared plus 9y squared equals 36, we can divide both sides by 36. So 4 over 36 is x squared over 9. 9 over 36 is y squared over 4. And that's equal to 1. Now I can, the next step would be to say this is x over 3 squared plus y over 2 squared is equal to 1. And now I converted it to this form. X over 3 squared plus y over 2 squared equals 1. Now this is called standard form. Where do the dilations appear in this form? Well, in the x direction, it moves 3. and that's right below the x. And in the y direction, it moves 2, and that's right below the y. So if you just looked at this in standard form, you'll be able to see that it moves to 3 out in the x direction, 2 up and 2 down in the y direction. All right, now plot x squared minus y squared is equal to 1. Now, first thing we do is subtract x squared on both sides. Negative y squared is equal to 1 minus x squared. Now, if we divide by negative 1, y squared is going to equal negative 1 plus x squared. Square root both sides, so it'll be plus or minus negative 1 plus x squared. So it'll plot both of these, and what do you see? Hopefully you see that that looks like a hyperbola. And hyperbola might be a new function or a new graph for you. It's not a function because the vertical line test will show that it's not a function. Now, if we plot the lines y equals x and y equals negative x, how do those lines relate? Well, if we took a look at this graph, hopefully you've graphed it on your calculator, you'll see that this would look something like this. And the y equals x is going to be an asymptote here. Y equals negative x will be the asymptote here. So it comes down, it gets closer and closer to this line as we move to the left and as we move to the right. Let's put an arrow at the end of this. All right. So here are our two equations. Did I do that graph wrong? I did do that graph wrong. X squared minus y squared should be that way. Wonderful. Hopefully, I should have just drawn it here. Or graphed it on my own calculator. And right now I should be using a straight line function because that would look a lot better. Alright. I'll get my act together here. That's the y equals negative x. That's the y equals x. And they're the same two equations that you would use for this function, or for this equation. So this would be y equals x, y equals negative x. If the negative is on the x, it goes up and down. If the negative is on the y, it goes left and right. And here, clearly the negative is on the y, so it should have been left to right. That's just a big mistake. Alright, so those are your unit hyperbolas. Plot this hyperbola. So it looks similar to the previous one, but it doesn't. The ellipse would have a plus, now we have a subtraction. So if we did the math, or algebra, negative 9x squared equals 36 minus 4x squared. Divide by negative 9, negative y squared is equal to negative, I should actually do this out, so 36 minus 4x squared over negative 9. So y squared is going to be negative 4 plus 4/9 x squared. So now I take the square root of both sides, so y is equal to plus or minus negative 4 plus 4/9 x squared. Now if you graph this, you'll see that the asymptotes now have a slope of 2/3 and negative 2/3. Now if we transform that problem so the right side is equal to 1, 4x squared minus 4x squared minus 9y squared is equal to 36. We do the same thing where we divide each side by 36. The right hand side is equal to 1. 4/36 is 1/9. 9/36 is fourth. So now if we take the squares to the outside, x over 2 and y, or x over 3 and y over 2. Each of those squared. I'm going to redo this bottom because it doesn't look good. And see where I get my asymptotes? It's the number under y over the number under x. So plus or minus 2/3 is the slopes of the asymptotes. Now remember, it's always slope is always y over x, so that's another way to remember it. Now let's do the equation x equals y squared plus y squared equals 1. Now it has only one squared term, so we subtract x on both sides, square root it. Hopefully you can graph both of those equations, y1 and y2, and see that that makes a parabola. There's a unit parabola, y equals x squared, and then there's the other unit parabola, x equals y squared. X equals y squared goes off to the right, y equals x squared opens up. So how can we tell if something is a circle? Well, the x and the y will always have the same coefficients. If we wanted to see if it was an ellipse, x and y would have unequal coefficients, but the same sign. If it's a hyperbola, x and y, x squared and y squared will have both opposite signs, and a parabola is the easy one. Only one of the two variables is squared. Now it's easy, but some people get caught up with searching for these three, and they forget about the parabola. So which of the conic sections is this? Well, we have 3 and a negative 2. So the coefficients in front of x squared and y squared have opposite signs, so we know it's a hyperbola. Now, the coefficients before x squared and y squared are both positive, but unequal, so we know this has to be an ellipse. These coefficients in front of x squared and y squared are exactly the same, so it has to be a circle. We have an x squared, but no other squared, so it has to be a parabola. Here, x squared, and y squared, none of the rest of the stuff really matters for just determining the conic section. The coefficients in front of the squares are going to determine it. And that's an addition sign in between. So different signs, or different numbers, but same signs. So this will be a ellipse. This one again, we just look at the coefficients of in front of x squared and y squared. They're the same, so that's a circle. This is x squared. There's no other x squared, so this is automatically a parabola. 3x squared, negative 3y squared, positive and negative, that makes it a hyperbola. Alright, now this one, if we would multiply it out, it would be 1/5 squared, so it would be 1/25 x squared, and then a whole bunch of other stuff. This would be 1/3 squared, so 1/9 y squared, so, and a whole bunch of other stuff. So all we need to do is look at those values. Both of them are positive, they're different, so that is an ellipse. This one, we'd have 1/2 squared, and there would be a negative on that, so it would be negative x squared over 4. And then this one would be plus y squared over 9. Now we could figure all of this out. We could figure out all of those other values, but in the end it really doesn't matter. This is negative and that's positive, so we know it's going to be a hyperbola. Alright, now you just have to do your homework. Good luck.